video covers Section 3, Part 1, Authenticating with AWS STS. As noted earlier in the module, the second aspect of security you'll learn about is controlling application users' access to your application resource. In the next two sections, you learn about using the AWS Security Token Service, also known as AWS STS, and Amazon Cognito in conjunction with IAM to control access to resources. As noted on the slide, it is a security best practice to use temporary credentials to grant permissions to your resources. To understand how AWS access control works, familiarize yourself with the following key concepts. Authentication verifies the user's identity, while authorization verifies the user's permissions, or what the user is allowed to do. An identity provider, also called an IDP, manages identity information and provides authentication services. An identity broker is a software layer that authenticates credentials against an IDP and retrieves temporary security credentials from AWS STS. And then we have the standards. The first is the Security Assertion Markup Language, also called SAML. It's an open standard used to exchange authentication and authorization data between parties. The second is OpenID Connect, also known as OIDC. This is an open standard that third-party IDPs use so other companies or sites can use them to authenticate users without having to maintain an in-house user database. Finally, JSON Web Token, also called JWT, is an open standard used to securely transmit information between two parties. As you learned in the IAM module, you can authenticate programmatically to AWS services through the AWS Command Line Interface, or AWS CLI, SDKs, and APIs by using your AWS Access Key. The Access Key is a combination of your Access Key ID and Secret Access Key. Embedding access keys in unencrypted code and sharing security credentials between users in your AWS account are bad security practices. If your application or application users need access to AWS services, you should configure temporary security credentials. You can use AWS STS to provide trusted users with temporary security credentials to access your AWS resources. Temporary security credentials consist of a short-lived access key ID, a secret access key, and a session token. You can configure temporary credentials to last from a few minutes to several hours. After the credentials expire, AWS no longer recognizes them or allows any kind of access from API requests made with them. Temporary security credentials are generated dynamically and provided to the user when requested. They are not stored with the user. When, or even before, the temporary security credentials expire, the user can request new credentials, as long as the user requesting them still has permission to do so. Thanks for watching. We'll see you in the next video. We'll continue Section 3 by discussing AWS STS Trusted Users. There are 4 different types of AWS STS Trusted Users. First, you can establish cross-account access for IAM users in one AWS account who need temporary access to AWS resources in another AWS account. To do this, you can provide temporary security credentials to an IAM role that the IAM user assumes. You can also use IAM roles with temporary security credentials to manage access to applications running in an Amazon EC2 environment and other AWS compute services. STS trusted users can also be federated identities. These are users who sign into your application from an authentication system outside of AWS. IAM supports 2 types of identity federation. First, there are Enterprise Identity Federation users. These are employees who are on a corporate network and are authenticated via a Security Assertion Markup Language 2.0 compatible enterprise identity provider, such as Microsoft Active Directory or Lightweight Directory Access Protocol, also known as LDAP. Mobile and web-based application users are also a type of federated identity. These users are authenticated via an online third-party identity provider, such as Facebook or Google. With federated identities, you do not need to create new AWS identities for users and require them to sign in to your application with a separate username and password. Instead, users can access your AWS resources directly using their corporate network. Here's how authentication with AWS STS works for federated users. A user accesses an application that is backed by AWS. The application calls an identity broker. The identity broker accepts a user's identifier as input. First, authentication. The identity broker first authenticates the user's identity against an identity provider, such as Active Directory for enterprise federation or an online third-party IDP for web federation. Second, authentication. If the authentication is successful, the identity broker makes an API call to AWS STS. The call must include an IAM policy and a duration, along with a policy that specifies the permissions to be granted to the temporary security credentials. AWS STS uses IAM to confirm that the policy of the IAM user who is making the API call has permissions to create new tokens. AWS STS returns 4 values to the identity broker: an access key, secret access key, session token, and duration, that is, the token's lifetime. The identity broker returns the temporary security credentials and token to the application. The application uses the temporary security credentials and token to make requests to an AWS service, such as Amazon S3. The AWS service uses IAM to confirm that the credentials allow the requested operation on the given resource. The following is an explanation of how authentication with AWS STS works with IAM users. A user accesses an application that is backed by AWS. The application calls an identity broker. The identity broker accepts a user's identifier as input. First, authentication. The identity broker first authenticates the user's identity by checking whether they are an IAM user. Second, authentication. If the authentication is successful, the identity broker makes an API call to AWS STS. The call must include an IAM policy and a duration, along with a policy that specifies the permissions to be granted to the temporary security credentials. AWS STS uses IAM to confirm that the policy of the IAM user who is making the API call has permission to create new tokens. AWS STS returns 4 values to the identity broker: an access key, secret access key, session token, and duration, or the token's lifetime. The identity broker returns the temporary security credentials and token to the application. The application uses the temporary security credentials and token to make requests to an AWS service, such as Amazon S3. The AWS service uses IAM to confirm that the credentials allow the requested operation on the given resource. Different AWS STS API operations return temporary security credentials. The assume role returns a set of temporary security credentials for existing IAM users to grant cross-account access to AWS resources. The assume role with SAML returns a set of temporary security credentials for federated users who are authenticated by an organization's existing identity system. The assume role with web identity returns a set of temporary security credentials for federated users who are authenticated through a public identity provider, such as login with Amazon or any OpenID Connect, OIDC, compatible identity provider. The Get Federation token returns a set of temporary security credentials for federated users. This API differs from assume role in that the default expiration period is substantially longer, 12 hours instead of 1 hour. The Get Session token returns a set of temporary security credentials for an existing IAM user. This is useful for providing enhanced security, such as allowing AWS requests only when multi-factor authentication, also known as MFA, is enabled for the IAM user. Thanks for watching. We'll see you in the next video. This video covers Section 4, Part 1, Authenticating with Amazon Cognito. Amazon Cognito provides authentication, authorization, and user management for your web and mobile applications. With Amazon Cognito, you can create unique identities for your users and authenticate the identities through a variety of IDPs. Amazon Cognito also provides temporary security credentials to access AWS resources and services. The two main components of Amazon Cognito are user pools and identity pools. User pools are user directories that provide sign-up and sign-in options for your application users. Users can sign into your web or mobile application through Amazon Cognito or federate through a third-party IDP. Whether users sign in directly or through a third party, all members of the user pool have a directory profile which you can access through an SDK. Identity pools, which are also called federated identities, provide your users with temporary security credentials to access other AWS services. The next slides illustrate how you can use identity pools and user pools separately or together. Amazon Cognito user pools provide several security features and functionality for user authentication. As mentioned before, Amazon Cognito offers sign-up and sign-in services, including social network sign-in with Facebook, Google, and login with Amazon, as well as sign in with SAML identity providers from your user pool. Amazon Cognito user pools come with a built-in customizable web UI to sign in users, manage user directories, and access user profiles. You can use an Amazon Cognito user pool to control who can access your API in the API Gateway. API Gateway validates the tokens from a successful user pool authentication and uses them to grant your users access to resources, including AWS Lambda functions or your own API. You can also use groups in a user pool to control permissions with API Gateway by mapping group membership to IAM roles. The groups that a user is a member of are included in the ID token that a user pool provides when your application user signs in. Security features such as checks for compromised credentials, phone and email verification, and adaptive authentication are also included. The compromised credentials feature protects your users' accounts by preventing them from reusing credentials, a username and password pair, that have been exposed elsewhere. This feature addresses the issue of users reusing the same credentials for multiple websites and applications. With adaptive authentication, you can configure your user pool to block suspicious sign-ins or add second-factor authentication in response to an increased risk level. A security best practice is to never use the same username and password in different systems. If an attacker is able to obtain user credentials through a breach of one system, they could use those user credentials to access other systems. AWS has formed partnerships and programs so that Amazon Cognito is informed when a set of credentials has been compromised elsewhere. A user pool is a user directory in Amazon Cognito. Your application users can sign in either directly through a user pool or federate through a third-party IDP. To authenticate, a user answers successive challenges until authentication either fails or the user is issued tokens. With these two steps, which can be repeated to include different challenges, you can support any custom authentication flow. You can customize your authentication flow with Lambda triggers. These triggers issue and verify their own challenges as part of the authentication flow. Challenges might include password verification, MFA enabled, CAPTCHA, or secret questions and answers. You can also use a Lambda trigger to perform post-authentication tasks, such as logging events for custom analytics. The user pool manages the overhead of handling the tokens returned from social sign-in IDPs and from OIDC and SAML IDPs. Whether users sign in directly or through a third party, all members of the user pool have a directory profile, which you can access through an SDK. After a successful user pool sign-in, your web or mobile app will receive a user pool token from Amazon Cognito. You can use those tokens to retrieve AWS credentials that allow your application to access other AWS services. Or you might choose to use them to control access to your server-side resources or to an API gateway. You can also create user pool groups to manage permissions and to represent different types of users. Thanks for watching. We'll see you in the next video. Section 4, Part 2, Authenticating with Amazon Cognito. When you sign in by using a user pool, regardless of where the identity lives, whether in the pool or coming from a federated third-party IDP, Amazon Cognito gives you 3 JWTs: the ID token, access token, and refresh token. ID and access tokens are signed, not encrypted, while the refresh token is encrypted. The developer's job is to take the ID and access tokens and pass them along to authorize access to application resources. The client must save the refresh token to silently refresh the ID and access tokens behind the scenes. By design, tokens live for a relatively short time. You can choose how long your access and refresh tokens remain valid. You can configure access tokens to expire in as little as 5 minutes or as long as 24 hours. You can configure refresh tokens to expire in as little as 1 hour or as long as 10 years. These tokens simplify identity for developers and provide the ability in a lightweight manner to pass user context to downstream services so that developers can easily get this user context. When using the user pool directory as your IDP, AWS hosts the entire experience. If you set up user pools to federate with a third-party IDP, Amazon Cognito user pools trusts those identities and redirects them as if the users were in its directory. The diagram depicts a flow that uses Amazon Cognito user pools with API Gateway. First, the client authenticates with the user pool and gets 3 JWTs in return. Next, the client passes the ID and access tokens in the header as part of the call to API Gateway. Then, API Gateway validates the token before it invokes the resource it integrates with on the back end. In this example, a Lambda function. And finally, depending on how you've written your API and application, API Gateway might pass on the ID token or access token. If you don't need to further scope the access allowed, pass the ID token. If you need to scope access further, you can use the access token and configure predefined attributes within the API method request by using OAuth scopes. You can use web identity federation in your mobile apps to enable users to sign in using supported IDPs. For example, log in with Amazon, Facebook, or Google, and to trade an authentication token from these providers for temporary AWS security credentials. The advantage is that you can build mobile apps without writing any back-end code to integrate with these IDPs. In addition, you don't need to embed long-term AWS credentials in your app. With Amazon Cognito identity pools, you can create unique identities for your users and authenticate them with web IDPs. With an identity, you can obtain temporary, limited privilege AWS credentials through AWS STS to access other AWS services. Amazon Cognito also supports developer-authenticated identities, which provides the ability to register and authenticate users through your own back-end authentication process. This diagram presents the overall functionality of identity pools. First, users sign in by using the credentials of their IDP of choice. Then, Amazon Cognito validates user credentials with the information received from the IDP and replies with permissions to access AWS services through an AWS STS role. Notice that in this view, Amazon Cognito user pools is just one other IDP, similar to Facebook, Google, and others. Amazon Cognito identity pools support Amazon Cognito user pools, public IDPs such as login with Facebook, Google, or Amazon, SAML IDPs, OIDC IDPs, and developer-provided authenticated identities. This example uses federated identities with IAM-based authorization to provide temporary IAM credentials. First, the client gets JWTs from the Amazon Cognito user pool and uses those to request temporary AWS credentials. Amazon Cognito identity pools validates the ID token and then returns temporary credentials. Next, the client uses these credentials to sign the payload and call the service API. Then, the service, in this example Amazon DynamoDB, checks the policy associated with the temporary credentials and allows the actions that the policy provides. Let's review some key takeaways from this section of the module. Use Amazon Cognito to manage user access to AWS resources. User pools are directories of users who can access AWS resources. You associate users with credentials in identity pools. Authenticate access with Amazon Cognito by using user pools or IDP credentials. Thanks for watching. We'll see you in the next video. It's now time to review the module and wrap up with a discussion of a practice certification exam question. In this module, you learned how to list two aspects of securing applications. Recall how to authenticate with AWS STS. Describe how to build secure applications with Amazon Cognito. And secure part of a website with Amazon Cognito. Now let's look at a sample exam question. A developer is adding sign-up and sign-in functionality to an application. The application is required to make an API call to a custom analytics solution to log user sign-in events. Which combination of actions should the developer take to satisfy these requirements? Select two. A. Use Amazon Cognito to provide the sign-up and sign-in functionality. B. Use IAM to provide the sign-up and sign-in functionality. C. Invoke an API gateway method to make the API call that the post-authentication event initiates. D. Store the database credentials in AWS Secrets Manager. Configure Secrets Manager to automatically rotate the credentials. E. Invoke a Lambda function to make the API call that the post-authentication event initiates. Note the key requirements stated in the problem. The developer is adding sign-up and sign-in functionality, and the application must make an API call to a custom analytics solution to log user sign-in events. Consider the answer choices and rule them out based on these key requirements. We'll pause a few seconds before discussing the correct answer. If you need more time to consider the answer choices, you can pause the video. So how do these answer choices compare to the requirements? Amazon Cognito provides user sign-up and sign-in functionality, so that meets one requirement. That might be one of the answers. IAM can be used to determine a user's permissions, but it isn't used for sign-up and sign-in capabilities. That's not an answer. API Gateway can only call endpoints that are AWS services, Lambda functions, or an HTTP web page, so that wouldn't work with the custom analytics solution. That's not an answer. Storing database credentials in Secrets Manager wouldn't provide sign-in and sign-up or provide a way to initiate the post-authentication event. That's not one of the answers. For the last option, a developer could create a Lambda function to make an API call to a custom analytics solution and then invoke that function with an Amazon Cognito post-authentication trigger. This one meets the requirements, so it looks like the second correct answer. We were right. The correct answers are A and E. That concludes this module. Thanks for watching. We'll see you again in the next video. Welcome to Module 13, Automating Deployment Using CI/CD Pipelines. This video covers Section 1, Introduction. By the end of this module, you should be able to describe DevOps, recognize AWS code services for continuous integration and continuous delivery, or CI/CD, describe how AWS CloudFormation is used to deploy applications, and describe how AWS Serverless Application Model, or AWS SAM, is used to deploy serverless applications. In this module, you will be introduced to DevOps and using AWS code services for CI/CD. You will also learn about deploying applications with CloudFormation, as well as deploying serverless applications with AWS SAM. Sophia wants to make the release process less prone to human error. She was chatting with Matteo, an AWS SysOps engineer, and he explained that DevOps is a philosophy and a set of practices and tools that support cloud application development, including automation of the development and release process. That's it for this video. Thanks for watching, and see you in the next video. It's now time to review the module and wrap up with a practice certification exam question. In this module, you learned how to describe DevOps, recognize AWS code services for CI/CD, describe how CloudFormation is used to deploy applications, and describe how AWS SAM is used to deploy serverless applications. Now, let's look at a sample exam question. A developer has reached the account quota for the number of CloudFormation stacks in a region. How could they increase the quota? A, use the AWS command line interface, AWS CLI. B, send an email to quotas@amazon.com with the subject CloudFormation. C, use the support center in the AWS Management Console. D, all service quotas are fixed and cannot be increased. Note the keywords in the question. The solution needs to increase the account quota of CloudFormation stacks. Consider the answer choices and rule them out based on the keywords that were previously highlighted. Let's pause a few seconds before discussing the correct answer. If you need more time to consider the answer choices, feel free to pause the video. So how do these answer choices compare to the requirements? First, the AWS CLI doesn't provide a command for increasing an account quota. For the second choice, AWS provides the ability to request quota increases through the console, so email doesn't seem like the best answer. For the third choice, the console does have a support center and it has a section specifically for service quotas. This is likely the correct answer. The final option is incorrect because some service quotas can be increased by request. The correct answer is C. Using the support center in the console, users can request a quota increase for service quotas that do not have a fixed maximum capacity. That concludes this module. Thanks for watching. We'll see you again in the next video.